a frequency table such as this, as we go down the rows, we add up the frequency. So here, if the frequency between times 0 and 20 is 2, then so far between 0 and 20, all we've had is a frequency of 2. Yeah, so cumulative frequency. If, however, we then wanted to go from 0 to 40, that would be the combination of these two. So that would now be a cumulative frequency of 8. If we wanted to go from 0 to 60, well, the frequency is still adding up. So you've got your 2, add your 6, now add your 16. That's going to give you a total of 24. 0 to 90, notice now the interval has changed. Instead of going up in 20s, it is now shifted to go up into a 30. We're adding another 4, so that's going to bring that up to 28. And then lastly, 0 to 120, add 2 more. We get a total frequency of 30. So not only has this helped us potentially just work out how many of these things are, let's say these are students, on how long it took them to answer a given question, time in seconds. So 30 students in total, 2 of which answered it in less than 20, 6 answered it between 20 seconds and 40 seconds, 8 therefore in total answered between 0 and 40. If we then wish to plot this on a graph, we do have to be using the cumulative frequency. If we were to plot the frequency itself, let's say we did that at the midpoints, so you'd have like 2 at 10, 60 at, 6 at 30, 16 at 50, 4 at the middle of that would be 75, and then 2 again at 105. And then just this would be the setup for a frequency polygon, where you then just joined up your lines. A frequency polygon is something different, it's its own concept, which pretty much is encapsulated there. You just plot the frequency on the axes and you join up the dots. Here though, no, we're not doing any of that. We are doing our cumulative frequency, we're adding up as we go, so we're going to be using these numbers here, and also we're going to be plotting at the end of the groups. So 2 is going to be plotted at 20. 8 is going to be plotted at 40. 24 is going to be plotted at 60. 28 is going to be plotted at 90. And 120 will be where we plot our 30. Joining these up then, that will give you a curve that looks something like that. On your actual paper, in an exam paper, you'll be able to do this a lot more accurately with the grid they've given you, and it should be a smooth curve. But regardless, cumulative frequency usually almost always has this kind of like stretched S shape. Well, now that you have this, you can start reading off the data. Now then, we could read values off this table. Let's say that the question asks you, what's the probability that a given student took longer than 40 seconds to answer the question? Well, from the table, we can just look and say, okay, that's going to be our 16, our 4, and our 2, because all of these are greater than 40. Add those together, you get 22. 22 out of this 30, or 11 out of 15. But let's say we didn't have the table. Let's say we just had the graph that was given to you. Well, we'd have to find our 40 and read up, and then carefully read across and find that that's 8. These numbers, however, are for below that value. So we're saying 8 people were 40 or less. So to get greater than 40, that's going to be the total of 30 minus the 8, leaving that with 22. Yeah, that obviously same 22 as before, 22 out of 30. So yeah, find the value on the x-axis, read up and read across. Be aware though that on the y-axis, this is how many are that or below. So if the question is asking for greater than and more than, then you have to get the total minus that. In a similar way, if the question had asked you for the median, so there's 30 in total, well, half of that is going to be 15. And we are looking at the y-axis first this time because it's out of how many in total, not what the time was. What was the time for the median student? Well, the median student is at 15, as we say. So you'd find 15, you would read across, and then you would read down. At least by my sketch here, that gets that person down at 50 seconds. So the median time was 50. If we were right with that, then let's have a go at giving you a question of your own. If we just erase these values here, I'm going to be keeping the times the same, so I don't have to change too much of the axis. However, the frequencies will be different. So what we're going to say this time is that the frequency for 0 to 20 is going to be 1. Then the frequency for between 20 and 40 is going to be 3. 40 to 60 will be 6. 60 to 90 is going to be 3 again. And then the 90 to 120, let's just make 2 again, from like last time. So, what I'd like you to do is first of all, fill out this cumulative frequency column, then work out what your scale has to be there for on the y-axis, plot the cumulative frequency graph, and then as a final thing, work out, using the graph, what's the probability that someone takes less than 80 seconds. Pause the video, have a go for yourself. You may want to get a piece of paper to draw this out on your own. When you're ready, then just press play again and we can compare. Alright, so for the cumulative frequency, first and foremost, if we're just adding them up as we go along, 1 added to nothing is just 1. And then add the 3 though, gets us 4, add 6 is 10, add 3 is 13, and then add 2 is 15. Our scale then has to go all the way up to 15, so let's probably just go up in ones. So 1, 2, 3, 4, 6, 8, 10, 12, 13, 14, then 15 at the top. For plotting, so at 20 we're going to plot 1. At 40 we're going to plot 4. At 60 we're going to be plotting 10. At 90 we're going to be plotting our 13. And then at 120 we'll be plotting 15. Just joining these up then, you're once again going to get your kind of stretched S curve shape. And then the last thing I asked you to do was to work out the probability that someone took less than 80 seconds to complete the question. Well, if we find our 80, then we'll read up and then read across. As I said previously, of course, on yours, you'd have actual graph paper, so you can be a lot more accurate. But here, that would come across as 12. So 12 of these 15 people got completed it in less than 80 seconds. 12 out of 15. If you wanted to simplify, that would be like 4 out of 5. And then read across. As I said previously, with yours you'll have actual graph paper, so you can be a lot more accurate. But here, that reads off as 12. So 12 of the 15 people completed the question in less than 80 seconds, 12 out of 15. If you wanted to simplify that, that's like 4 out of 5, if you cancel through by a factor of 3. Alright? Okay. If we're happy with that, let's just see how this compares to an actual question from a paper. So here you can see they have provided you with the grid which you're going to plot onto, and we're told that the grouped frequency tables is grouped because we're not getting the actual wages of each individual employee. We're just saying, okay, 8 of them were between this and this, so forth. Shows information about the weekly wages of 80 factory workers. Now, complete the cumulative frequency for this, first of all. Well, as we've been doing, we're just going to add up as we go along. So to start off with, the first row, that just stays 8. But if we were then to add 15 to that, that's going to get us to 23. Add 30 is going to be 53. Add 17, that's going to get you to 70. Add 7 is 77. and then lastly add 3 is 80, which we know is correct because they told us there were 80 in total. Now that we have this cumulative frequency, we plot onto the grid. So this is the graph here is starting at the range 100 to 200, and it has to start at 0. But in either way, we're now going to start plotting at the end of the group. So this at 200, we're going to plot 8, which is going to be here on your scale. At 300, we're going to plot 23. At 400, you're going to plot 53, which would just be here. At 500, you're going to plot at 70. At 600, you're going to plot at 77. And then lastly, at 700, you're going to plot 80. And just as we're actually joining these dots up, we are going to be starting at 100, not 0, because that was the beginning of the first group. So from 100, we then try to draw our curve going smoothly through these points. That elongated S shape looks about right. That's us having plotted. Part C. Use your graph to find an estimate for the interquartile range. Now, we haven't talked about interquartile range in this video yet, but just to explain, if there are 80 workers in total, their median would be 40. What would then the median of 40 be? What halfway 40, that would be 20. And then similarly on the other side would be 60. So the interquartile range is working on what's a quarter of the way through the total frequency, and what's 3/4 of the way, what's 25% and 75%. We then, for these values, just read across and read down to get a value here. So this, if each little box is going to be 10, we can read that off as 440. And then here for the 20, we go across and go down. We can read that as 290. The interquartile range then, if we call this the upper quartile and the lower quartile, the 75% and 25%, it will be upper quartile minus lower quartile. So in this case, 440 minus 290 gives us an interquartile range of 150. Lastly, use the graph to find an estimate for the number of workers with a weekly wage more than 530. Okay, so we're starting with the wage. You'll find 530, so it's going to be here. Just work our way up to the line. If you're doing this on your actual paper, I would always advise using a ruler to make sure that you're going straight and you follow the line. Then if we just read across here, that's going to be at 73. Now, that 73 is at 73 people with 530 or below, so more than 530 is going to be the total, 80 minus that 73, leaving us with 7 workers who are earning more than £530.